All attendees are in listen-only mode.
Hello and welcome to today's webinar. I am Stephen from Ventus, and in today's webinar I want to show you Ventus in general and give you a rough overview of our software suite, our solutions, our products, and give you a small starting point to get an idea of what you can achieve with Ventus. I think we should wait 2 more minutes because there are still people joining us. Let's just start at 4 p.m. so that everybody who wants to start from the beginning can do so, even if he's a little late. Until we start, just so you know from the start, I will present you the general things about Ventus for the first hour, and afterwards we have some time for questions and answers. So you can just drop your questions and I will collect all of them and answer them in the end. Okay, so there are still 1 or 2 people dropping in, but I think we should start now. So let us start to talk about general things of Ventus. As you may know, Ventus is a real-time compositing software, so you are able to composite 3D content together and play it back all in real time to make it interactive or to control it with the control software in real time during rendering. What we do is provide a whole palette of solutions, so we try to support several markets with our products. We focus on several markets and focus on several solutions, but Ventus basically is just a tool set that you can use to really get creative of what you want to achieve with it. There are about 17 markets or 17 solutions that we really focus on, that we try to make solutions for that are very easy to accomplish and to implement. But as said before, you can above that create just everything you like to. So Ventus is designed to be very flexible and still give very easy solutions to common use cases. To start, I will just want to show you the most common solutions, which you can also see on our website, which is ventus.com. And here you can see that we have summarized this to about 5 solutions, which is first being very flexible in output devices, which means that you cannot only display it in HD resolution on one single display or on a touch screen or something, but also on very high resolutions. And if you want to achieve like real high resolutions, you can either play out on several LED walls, or you can cluster several machines together that all render the same scene on different monitors or displays, and all this in real time again and all synchronized, so that you can drive really high resolutions. Next, since we offer a real-time rendering software, we are able to give the opportunity to implement interactivity, which means that your end user is able to really interact with your presentation or with your during your event or during your broadcast show. Your operator can also still change everything on the fly. This means that we also offer solutions for very easy to implement interactivity for multi-touch displays, or also for video walls. As long as you have the hardware to implement interactivity, Ventus is able to read that. And it's just as easy as placing a node, which is the basic component of a Ventus scene with which you can build your presentations, and you can just add one more component, and then you're good to go with interactivity. But we will have a look at that later as well. Next big market for us is the broadcast market. So besides the event and the presentation market, we also support the broadcast market, which means that we, for example, offer SDI solutions, or we can also control several machines for in-studio graphics, like a video wall or touchscreen in the studio, and also on-air graphics during broadcast from one single point, for example, with our director software. Or if you want to use anything else, we just also offer a remoting API, which you can use with several other software that is already produced out there, or you can write your own software, which also some people do. Next big market is interactive presentations, for example, for company presentations. So you are able to not only create linear presentations like with other software like PowerPoint or something, but you're also able, through the interactivity and the flexibility of Ventus, to create, for example, tree structure presentations, or whatever structure you like you want to implement, and whatever makes sense for your presentation you can do with Ventus. Lastly, which goes somehow, or is very similar to the first solution, is the projection mapping. So we do not only support very high resolutions, clustering of several machines, but we also offer a projection tool so that you can map and shape and warp your projections on your screens that you have on your stage or on the building or wherever you like to project onto. So those are our 5 main use cases and our 5 main solutions. Just again, those are our main solutions. There's a whole lot more that you can achieve with Ventus once you know about its flexibility, and I think you can, in the end, can manage to find out how flexible all this is and what you can probably achieve with Ventus. So now, how to achieve all these solutions, how to produce such a project that is able to drive on high resolution video walls, for example. For this we offer 3 basic products, which you can see on our website as well. This is 3 software solutions. The first one that you will get in touch with is probably the Ventus Designer, which is always the starting point of a project. I can show this in a small schematic a little bit better. So you will start always with the designer and start to create a project file, collect all the assets that you want to use in your project, for example, geometries, movies, images or textures, and also data files that are providing, for example, Excel files or XML files for real-time data. And all this you will combine with the designer and composite, creating a presentation in the end that you can then play out with our second software, which is the runtime, which is just a play out device. So you can actually play back what you create with the designer. And the third software, I already mentioned it, is the director, which is able to control an already playing runtime. So that, for example, if you have a broadcast show and you create several graphics for the broadcast show, like a lower third, the director is able to fill the graphics with data, for example, a text line on your lower third, and tell the runtime what is the text line and when to play the lower third. So this is the basic of our software suite. First, create a project with the designer, create a presentation with it, play it out with the runtime, and optionally control it with the director. Of course, you're also just able to play out with the runtime, and when you don't want to control anything from outside, which is also possible, for example, on an event, on an exhibition, where you just want your users or your visitors to play around with a touch wall, for example, this is also, of course, possible. So the director is really optional. So much about our software suite. Let's just very fast jump into our license model. This is just a very rough overview. In the end, if you need more information about our licenses, contact our sales team, which is sales@ventus.com. So the license model basically provides you with one license for each of our products. So we have one license for the designer, one for the director, and one for the runtime. Except that for the designer you also need a runtime license, so this is why we provide a runtime license together with the designer, and the same goes for the director. By default you're able to output with your runtime on your GPU, and if this is enough for you, you don't have to do anything else. Then, for example, buying a designer license, then you can already output on your GPU. But you can optionally buy or add SDI options, NDI options, or several other options that are very specific, like broadcast package where you get an additional codec, tracking systems, and all that. So basically, one license for each product. You can buy a runtime on its own, or a designer with a runtime, or a director with a runtime. By default, you are able to output on your GPU, and you can buy options like SDI options or NDI options and so on. So much to our basic license model. This is basically everything about the philosophy of Ventus. The most important parts are that Ventus is a tool set consisting of 3 different products, which is very flexible since you can design for every use case. You will always start with a designer, and so you are also very flexible in combining your use cases. For example, for in-studio graphics, you're also, of course, able to drive a video wall, which has a very high resolution, or you can drive your on-air graphics in your arena of a sports event, also on a very high video wall, and just show what's shown on air. Or the same goes for interactive presentations, which can also be combined with projection mapping, for example. So this is a very flexible tool set and a very mighty tool set, which just enables you with 3 different software products and programs to achieve whatever you can imagine to achieve with it. So this is all about the basic philosophy. I think we can now jump directly into the most important product, which is the Ventus Designer. And I can show you the basic workflow with the Designer. so that you get an idea of what the new workspace could look like. This is our very simple design view. So the Ventus designer has several views or user interface modes which are focusing on different use cases. So the first one is the easiest one, which is the design view. You just have a renderer window, which is very big now here in the middle, which is currently showing you really what you will see in the presentation later on. So once you deploy your presentation, you will most likely have exactly what you can see in the designer. So Ventus is definitely a what you see is what you get software, which makes it very easy to debug stuff and all that. Next window in this design view is the layers window, which is the first entry point into every scene of your Ventus project. So basically a project always consists of several Ventus scenes or just one, whatever you like to work with. And each Ventus scene is then consisting of several layers, which are each providing the scene with one texture, which will then be blended together. So when we want to add a new layer, to just showcase this, I will want to just press the plus up here, go to 2D layer, and add, for example, a color layer. So now I have a constant color, a solid color layer on top of all the other layers that I rendered before, and it is just rendering everything in white. So probably this is somehow boring because what we saw behind is a little bit more interesting, but we can, for example, blend this to make it more interesting. So we have several blending modes for each of our layers, since we're just rendering our textures, which are 2D, which can be composited in a 2D way, which you may also know from other 2D compositing software like Photoshop. And so we have all the blending modes that you know from the 2D world. For example, we can multiply, make this more interesting by turning this red instead of white. And now you can see that the red constant color is multiplied on top of my other two layers, which are rendering the logo and the background. So all these blending modes have their names from 2D compositing in the end, because this is actually real 2D compositing in real time. So now this might be very boring, and I don't want to always work with just constant colors. As long as I want to stay in the 2D world, I can, for example, also add a Photoshop file. So I can add a Photoshop layer and search for my Photoshop PSD file and add it so that all the layers in my PSD file are added as actual Ventus layers in my scene as well, as you can see here. So I have a layer for my background. When I make this invisible, I can see my old scene again, which is still rendering in real time. And my Photoshop file textures are rendered on top of it. So again, those are still layers like my solid color layer, which I had before. I can still again change my blending. For example, if I want to, I could, for example, blend this by multiplying or by screen blending or whatever I like. And additionally to blending, we offer a palette of image post-processing effects which are applied in real time. So image post-processing means that we have some 2D post-processing effects like, for example, a blur, which I can apply to single layers of mine, which are not applied to a 3D world, but to my 2D textures of my 2D compositing. So instead of a blur, I can also correct my colors, which probably doesn't make sense with a black and white layer, but more with an orange layer. So just so you see some different effects with that. So this is my 2D compositing, but this is just the top, or scratching the very surface of Ventus Designer. Because the real Ventus world starts with a 3D compositing, which can be done by adding, instead of just using 2D layers, we can just add a 3D layer, which will then enable a hierarchy, like you know from other 3D software like Cinema 4D, Autodesk, Maya, whatever, and which will tell a 3D render engine what to actually show on screen in real time. So to showcase this, I will just use another scene which is showing this a little better. So this scene is just an empty world. I can show you by switching from the design view, which is just using the 2D compositing, to the logic view, which is also showing the 3D compositing editors, which consist of the hierarchy editor, which holds the hierarchy that tells the render engine what to exactly do. Like for example, if I want to tell it to render a torus, I can add a torus node, and for example an axis in front of the torus to reposition it, to scale it or rotate it. So those nodes in the hierarchy editor just directly tell the engine what to actually show on screen. Next we have the content editor, which is there to provide the hierarchy nodes with values that will affect the way the hierarchy nodes are rendered on screen. So for example, a hierarchy node is this mover node, which has inputs and outputs, which you can see in this property editor, which is the third editor. And this mover node is doing nothing else than just generating values for its output. So it has a minimum input and a maximum input and a duration, and during that duration it just goes from the minimum to the maximum and generate values. So we can, for example, use a preset to let it rotate, or to make a rotation animation, which is just generating values from 0 to 360, which will resemble degrees in a second. Let's change the duration to 5 seconds to make this a little bit more beautiful. And now we can, since we can also change the rotation with the axis, I can just tell this axis node to take its, for example, Y rotation from the output of my content mover node. So now my mover node is generating values from 0 to 360, and this is applied to my Y rotation of my axis. So this is the basic of working with the 3D engine, but this holds a little bit more than just generating generic geometries, placing them and changing the behavior of them, the exact behavior with content nodes. I can just very shortly show you the palette of nodes that we offer. So this is the toolbox of all the nodes, which are organized in a whole lot of categories, like geometry nodes, all world nodes, or all our interaction nodes. So as you can see, for example, in the geometry, we have a whole lot of different generic geometries, like a sphere, circle, cube, cylinder, and all that. In the world, you can find different methods to place and arrange your your geometries or your objects in your scene, like with an axis, with a range node, and all that. Here you can also find cameras and all the like. We have, for example, a text category where you can find everything that will render text on screen, also in real time, or animation nodes like the mover, which is in here. So there's a whole lot of nodes which a Ventus scene can consist of. So as you can see, also our layers are basically nodes and cannot just be found in the layers editor, but also in our nodes toolbox. Now I talked a lot about generic geometries, but what if I want to import geometries that are created in another software? There are two ways for this, and I want to show you both. The first one being just using an import a geometry import node. So let me just open a scene for that. This is again our world node, which is just generating this world here. And now in my geometry category, I have a geometry import node with which I can change in the properties editor. I can change which asset to import. For example, the sphere stand. So this is now not a generic geometry, but something that we created in another software. And now you can see that it generates a very big hierarchy just to render the sphere map. It has a material and some translation rotation axis. And in the end it has a mesh loader which will just load the imported mesh from your assets folders in your project. So if you want to change how exactly this sphere stand will look like, you can, for example, change the material in front of it. You can delete it and use another one, or you can just, for example, add a texture that will be applied to, well, let's not use that one for this, but so that you can see this. So this is now the texture that is applied to the cube, and this way you can change how the imported mesh will look like with Ventus nodes. This is the more basic workflow of importing custom geometries, which is exporting your geometry from your 3D software which you use to create the mesh, and then using this import node in Ventus and import the mesh. But instead of using this, you can also use our Cinema 4D Live link, which will make iterations of this a lot easier. So if you import a mesh and you find that it's not looking good or it has too many polygons or something like that, you will have to re-export it and re-import it in Ventus, and this may take some time. To fasten this up, we thought of the Cinema 4D Live link, which is able to connect to any instance of Cinema 4D running. So here I have my Cinema 4D scene, which is now just holding a NASCAR, a very simple NASCAR model with very simple materials and all that. And now you can see in this Cinema 4D scene that it's also holding a very basic hierarchy, which is just holding a car transformation, then dividing it into body and internals, and again having the several different meshes applied. So to use this, you will have to install a plugin which provides you with so-called Ventus tags, which will first create a setup link to which you can connect to. So with our geometry import live node, so we have the geometry import and the geometry import live node. You can now, with using this live link button down here, you can connect to each setup link tag that you can find in your Cinema 4D scene that is currently running. So I want to now connect to our car object in my scene, which is the one which has the setup link tag. And the second tag is the Ventus object link tag, which will then tell basically which objects to actually link to Ventus. So all I have to do now, once I am connected to my Cinema 4D 4D instance to my car object, I can just hit the update button, and just like with the geometry import, it will generate a hierarchy that resembles my NASCAR. So as you can see, this is a very similar hierarchy like you can see in our Cinema 4D scene. So again, we have the car basic object, which is the parent of all of my other objects. And again, it's divided into body and internals, and then consisting of several objects like the tires or the glasses or the body of the car. So now here you can see how this will look like in Ventus. Now we can already see one problem. For example, it's okay that our car is looking somehow chrome-like, but the tires should really be not using specularity. So to do this, I can just tell all the Ventus object link tags what to exactly send over to Ventus. Because if I'm not sending anything, Ventus will just use default values for that. So for example, with my tire, I generate a reflectance, which is not the default one, but a very low one, which is changing how reflecting the surface will look like. So in my object link tag, I can see that I'm not sending this reflectance or specularity. To do so, I will just have to change this for all my tags for all my tire objects. And once I hit that, and let's just be sure and update. Whoa. Also force a refresh on this side. Well, so I can see that this is now also generated on the Ventus side. So this is the setup that I have to do for the live link. I have to tell Ventus what to exactly link. So this might not take some time, but just some trial what to exactly send, which is basically everything that you have on your material. And once I've done this, I can just really send over everything that I change in my Cinema 4D scene. So let's rearrange this so that we can actually see something on screen. So whenever I change something here, for example, replace some object. I can see this live on my Ventus site as well. Replace the somewhere here. And what's more is that whenever I cannot change the position of single objects, but I can also change the meshes. So for example, I can create a deformer explosion for all my body objects. And whenever I animate this explosion, this will also be transferred to Ventus. So also I can make an animation out of this and also send this over to Ventus. So for example, animate the strength property. And now for these three tags, I will just want to create an animation. And now I can use this on my Ventus side as well. By just animating a property, and which again can be changed by, for example, using a mover. So no, let's not swing it, but like this. So you can see that I can now animate with my Ventus logic what I just created in Cinema 4D. So this is the second workflow that you have to import your geometries and also use deformers or effects that you created in Cinema 4D and reuse them in Ventus. So much for the 3D workflow. You might now want to learn more about the Ventus workflow in general. So as I've said while talking about the solutions, it is very easy to implement interactivity. It is as much as adding one more node to your 3D scene. So we can show this. Let's just show this in the scene. Somewhere here, like two. So now let's scale this up. Change the camera. So that we can also see our camera, so our car. So now I have my car, I have a camera that can see the car very good, and the car is scaled a little bit up, and all I have to do to make this car, for example, be able to rotate is add a touch orbit node. So to showcase this car, all it takes is add a touch orbit node, and now I am able, through touches, to rotate this car around. This is also possible for example, translations. So I can also move my car with the translation node, and there are a whole lot of other transformations that I can use. That I can show you again in our toolbox with the interaction nodes category. So there's a translation, an orbit, a rotation, a transformation which you can also rotate and scale, and that's basically it. So the other nodes are, for example, a touch paint node, which we can just draw on our 2D touch screen, which is very easy to, for example, test our touch screen, or to create some scenes for events that will demand some creativity from your visitor, or things like that. What's also very interesting is the touch button node. which is generating so-called events whenever a user is entering your geometry that lies behind the touch node, or whenever he's pressing or touching the objects. So all this touch interactivity, as you can see, also works with the mouse or with whatever interaction input device you want to use. So what you can do, for example, with this touch button is create a scene that uses, for example, a set of buttons to control a turntable for a product presentation or something like that. So you can create several states of your scene, and with these buttons you can translate to those states. So for example, in state 1 you want to show one product, in state 2 another one, and in state 3 the next one. So you can create a keyframe animation that just resembles those different states and translations between those, and you can trigger those with these buttons. So in this case the states is just a rotation of a torus, as you can see. So in state 1 it just has no rotation, in state 2 it has a rotation of 120 and 240 for state 3, and then it rotates back to 0. Very simple logic, I have to admit that, but it shows basically what it's capable of. So what I do for this is just I have created 3 buttons which work very similar, and in here I have a touch translation which also works as a touch button. So as soon as I tap or touch this button, I can very easily fire this event, which will then fire the translation of my animation. Which brings us to our next topic, basically. I think this will basically wrap up the interaction part of Ventus. As told before, this seems very easy to implement. So what makes this scene complex is all the visual stuff, like changing the render behavior of the scene and all that, and placing the nodes, animating them, and coloring them and all that. So next, let's talk about actual animations. We had a look before at the mover node, which is just generating values very generically. So you just type in a minimum and maximum value. You can generate this in very different modes. But this might not what you want to use all the time, because with keyframe animations, which you know from other software, you will have a lot more control over your scene. And this is what we offer as well. So we will have to jump to our next designer view, or the view mode, which is the animate view, which now adds one more editor to the hierarchy content properties and layers editor. We have the animation editor. And here you can create either very linear animations, which you can then animate. So let us do this very fast with our empty world. Add a torus, add an axis in front, let this rotate around the y and x axis, add 2 keyframes to it, like you know from other software, and well, let's scale this a little so we can actually see something. And you can, for example, let it rotate from 0 to 360 degrees to make some animation looking like this. You can also replace keyframes. So, for example, to animate forth and back, you cannot only place them in time, you can also adjust the curves of them with these handles, which might also be very comfortable. Now what we can do is just tell this animation to autoplay in a loop and not swing. And now you can see that it's just playing back the animation over and over again. So this is how animating with the keyframe animation very basically works. What I did here is something a little bit different, because I didn't want to use a linear animation, because you might already notice that building a turntable logic like I built here with 3 different states of the scene is very uncomfortable using linear animations. So there's a concept of Ventus which instead uses state logic instead of just linear animations. So what you do with the state logic is creating different states of your animation, which the animation can be in, and then defining translations between those states. So we have, for example, the state S1, which has a transition to state S2, which has a transition to state S3, and this one has a transition to state S1 back. I created those 3 states. I can just do this by double-clicking somewhere in this logic editor. And now to create a transition, I will just have to drag and drop from one state to another one. So once I double-click one of those transitions, it takes me to the linear animation between those 2 states, where I have full control over all properties and how they should be animated to get from one state to another one. So if I didn't want to just very easily animate from 0 to 120 to be from state 1 to state 2, I can add, for example, one more keyframe and change the value here. So I have some more interesting animation. I can also add more properties, of course, like I did before. But this is basically what I can do with state logic. So what is the advantage of using state logics? The biggest advantage is that you can create interactive animations. So once you have linear animations, you can just play it back from start to the end, and maybe from the end to the start back. But as soon as I have this state logic, I can add even more states to this. I have full control over going from one state to another one by, for example, button presses with this logic that you might know. Yes. So this again is first the advantage of using real-time rendering, and secondly the advantage of using a state logic, which is enabling you to flexibly respond to input of a real-time user that is standing in front of your presentation during runtime. So you can also, of course, make this remotable. You can not only make this touchable for an end visitor and end user, but you can also make this accessible for your operator of your, I don't know, broadcast show or the presentation that you want to hold. So this is all about animation, basically. The last thing we want to look at is real-time data, because this is also again something that you can obviously take advantage from during real-time rendering. So here I have a scene which is a very simple bar chart in my very simple world, which resemble, I can show you, also a very simple Excel sheet. So this is my Excel workbook, which just holds 5 values between 250 and 500, and I just built a very or a rather small logic. This still is, I would say, medium big, which is just transferring the values of my workbook to a scaling of my cubes, so I can build some bar-like chart. So the cool thing about this is that as long as I have this certain flag, which is called auto update, as long as that is turned on, I can change my Excel sheet also during runtime. For example, I can change this very lowest value from 250 to 1000, and as soon as I hit save for this Excel sheet, it will automatically update in your presentation. So this allows for example, having polls during your broadcast show, or if you want to create a show in general which holds very dynamic data which you just know during show time about, like if you're holding a company presentation and you want to have the latest data for some showcases, you can just use, for example, an Excel sheet. You can use a database, of course. You can use XML files or whatever you like want to be input in your presentation, or what is the most comfortable way to get your data, and then you can just visualize it with Ventus in real time. So every change that you make to your data input will be applied to Ventus in real time, which is a very big advantage of first real-time rendering and then the data flexibility of Ventus. So much to external data and how to use it in Ventus. And lastly, and very shortly, I want to show you our more graphical features, which is our new render engine, which is somehow going in the direction of physical-based rendering, but is not exactly physical-based. Which means that we have an HDR engine, but still the properties of a Phong-based material. And we added to this roughness and all that, or image-based lighting, which makes it somehow physically based. Let's just take a look at this. For example, we build a small robot, which is using one material for each of its parts. So for example, for this arm, I have one material, as you can see here, for the left arm, which is holding a base color, a normal map, a specularity, and a roughness, which is very similar to what you want to put in when you're physically rendering. But still you can see it is using a Phong-based lighting model. So additionally to this somehow hybrid material system, which is also very flexible, very mighty, you might want to take some time to really understand it, because the basics are very simple. You can just add those textures and it's still working, but you can also do a lot of tricks with those to make your scene look even better. So this is our material, which is one very big part of the graphical user interface of Ventus. And second part is our HDR and image-based lighting rendering. So first we can change your behavior of the engine from our standard engine to our high dynamic range engine, which is then using those properties that you might know from HDR engines. Like the exposure, you have a tone mapping to change the white point of your 3D rendering. And furthermore, you have different 3D effects that you can apply to your scene, like a real-time screen space ambient occlusion, which you might not see in this scaling, a depth of field and a bloom, and an image-based flare. So this is our, let's say, a 3D render engine which is capable of HDR. Next, as I told, is the image-based lighting, which can, for example, be accomplished with a skybox. So let's just draw the sky. We can change, we can add two textures to it. The first one being just the irradiance lighting, which just changes the diffuse lighting on your models, and the reflection lighting, which changes the specularity on your models and creates the reflections on them. So this might be a little too bright. Let's just turn this down. So now you can see an evening sky with an evening robot. So this might come in handy for example, virtual sets. Image-based lighting allows you to just create 6 images of your real studio and import it in your virtual set to create a lighting that is matching the lighting of your virtual set, of your real set in studio, just as an example. So I think this is it about our graphical features. Next, I want to lastly show you how to output your project that you just created. So this is somehow the same graphic like I showed you before with a workflow. This is just showing you the two workflows in more detail. So you can have an open scene in your Ventus designer, create a presentation out of it, and just play it back in your runtime as a single scene. Or alternatively, you can have the whole project open in your designer, then start the whole project in runtime to make it accessible to remote applications, for example our director, the Ventus director, to have access to not just one single scene, but dynamic scenes, and load every scene independently from each other. So I can show you very shortly those two workflows. Let's just use this button scenes for that. So this is the scene that we just changed. I will just save it and export it as a Ventus presentation. And this is basically all you have to do. I can now just hit save. I will now tell it which assets the scene consists of, so it is automatically searching for all referenced assets, and whatever asset I don't want to take with it can be deleted. So it's now exporting the presentation, and I can navigate in my Windows Explorer to the directory of the presentation, and then just by double clicking I can start the runtime. And here we go. This is the exact scene that we just saw in the Ventus Designer. And as I promised, this is what you see is what you get software. So you can see that whenever I hit one of those buttons, you can see the animation that I just created, and the scene looks totally like it looked in the Ventus Designer. So this is one way to just show one single scene on your presentation. Let me just show you the second way, which is oops, like this, using the Ventus director. So I just exited the Ventus designer, and I will bring up the Ventus director, which is, as I told before, control software, which I want to show you as well. And I can open a show with it. it is using a certain topology. Oh. Which is just, right now, it's just a local one, because I just want to render on my control machine. But once you want to, for example, have a production machine and want to control it with your director machine, you will have to add more machines to this topology, which is very easy. So now what I can do with the Ventus director is, first I can drive templates. So I have a templates-based workflow, which means that I can just create graphics in the Ventus designer and make certain properties of it accessible to the operator of the director. So for example, for the backgrounds, I don't want to have any properties available. I just want the operator to cue it and play it back. So during queuing, I am able to have a preview of this and change values that I have access to, and I also have a preview of the current program. So this is again just a preview, not a quality preview. This is just showing what is currently going on in your show. So now I can, for example, add a template which is holding more data, for example a circle diagram which has several data values which you can change. So for example you can let us, for mobile applications, let's change the value to 50. For messaging software, let's change it to 12, to, well, 12, 15, 24, 5, and you can see in the preview that it's changing in real time again, and updating the diagram as well, because I just defined so in my Ventus designer. And now as soon as I play this, it will be rendered on top of the background in my program view with a designed animation and visualization of my data that I typed in. So this is just showing template-based workflows that you can change on the fly. Of course, you are able to plan a show. You don't have to type in everything on the run. You might also use pages which use a template and give you predefined values for it. You can create playlists and use the timeline to first record a show and then play it back again. And also you're not only able to type in some text or integer values, you're also able to use assets. So for example, I have a template that shows some images of my company, for example, and now I can change those using my assets and play it back again as a template. So this is basically it for the director, and also for my deployment workflows, because instead of the director you can use any other software as well. It's just using the same API, which is called Remoting 4 of Ventus, and you're able to control the Ventus project or your Ventus presentation with any software that you like, but we provide a very sophisticated software, which is the Ventus Director. So this is it about the deployment. Next, I want to very shortly show you how to configure your machines with which you want to produce. For this we have a configuration editor, which you can see here. This is able to create configurations of several preferences of your machine that you're currently working on, but you can also change to any other machine and change the preferences of that one on the whole network. So for example, if I have a cluster video wall, I can change to the whole group and change the render setup for the whole group. Let's just add a new one. So in this render setup configuration, I can now create, for example, if I'm using 3x3 cluster, with each cluster using, well, new one, 3 displays. I can just create this, rearrange the displays like I want to very easily by dragging and dropping, or with my arrow keys, and add, for example, a bezel to them so that they compensate for those. So this is very easy to use. As I told you before, also creating projections is very easy with our projection and shaping tool. So you can change very easily how to exactly warp the projection onto your screen. You can create soft edges with those. Whoops. And color correct your output. So very easy to use, but no time to really jump into that, because this is a whole topic on its own to create video wall setups, projection mapping setups, and all the like. So just so you have a rough idea of the configuration and all, there's a machine configuration where you can change the culture settings, and the general remoting settings for remoting 2, for CLI remoting, OSC and all that, your 2U settings, and as I said, the culture settings. You can change your tracking system and all the like. Then we have an audio video configuration where you can change your outputs. As I told you before, by default you are able to output on your GPU, but you can also add NDI or SDI options, or you can add tracking system input options and all that. You can change your audio devices, create cross points for them, and change the video mapping or audio mapping and all that in here. The layout configuration, we had to look at that, and you can also remotely start and manage the projects on other machines. And this is basically about the configuration editor. Again, very mighty, because you can configure remote machines when you don't have physical access to them, which is very comfortable for setting up any kind of setup that involves more than one machine. So this wraps up the overview of Ventus. We had a look at the basic philosophy, what Ventus exactly is, of which products it consists, which solutions we aim to offer. We had a very rough look at the most important product, which is the designer. We had a small look at how to deploy projects that you created with your designer, and how to control the presentations that you create with them with the director, and we had a very small look at the configuration editor. So I think this ends this presentation of the Ventus overview.